retake. Hopefully you have a chance to ask questions in class and figure out what you're not getting. Then the rest of the class, if you are not planning to retake and you haven't watched the videos and read the textbook for 3.5, use your time to do that so you don't have to worry about that tonight. We'll do the textbook check for 3.5 tomorrow morning at the beginning of class. If you have looked at Canvas grades, which you should be doing regularly, you'll notice last night that I put in the Chapter 2 tests like I said I would at the end of the quarter last quarter. I didn't count it last quarter. Told you I would give you an opportunity to retake. And last week I said the retake was due yesterday, but nobody had come in to retake, so I'll leave it open to retake. But you have to finish the Khan Academy sections that I assigned to you. And if you have not already let me know that you've added the class or you've accepted to be a student in that class, let me know, because I have to assign the work to you after you're in it. You don't automatically join and then have the assignments. So I have to do that manually. So make sure if you're planning to retake that you have an opportunity to get registered for Khan Academy. The instructions are on the first quarter announcements on how to do it, what the code is, all of that. So once you're in, let me know. Either text me or call or email me. I'll get the assignments to you. You have to complete that before you can retake. There's no point in retaking if you haven't learned anything new and you don't know why you failed the first time. Questions on that? Yes?
So are we using the second quarter one now?
Yes. Everybody should be in second quarter. Yes. Any other questions before I get started on this quiz? Okay. So just a few general comments on the quiz. I had 100. I had several A's. I had quite a few B's. So I'm pretty happy overall with the results. Jaden was the only one that I saw did all the CK12. I had a couple that just did like 1 or 2. So if you think that you did CK12 and I didn't see it, at the end when I go through the quiz, you can pull up those and show me. Okay. But while I'm talking, I'd prefer that you aren't working on your computer, if possible.
So we can delete the first one?
You don't delete it, but you can just not put it on your, you can take it off your dashboard.
Your courses and uninstall it.
Okay. Okay. All right. So general comments. That's what I was talking about. Yes. Oh yeah. You need to take it while I'm talking. So I'm recording this, Corey. If after you've finished, you can watch the recording if you need to. There's a piece of graph paper on there too for you. So I'll wait for a second and then get started.
It's definitely not because of the books. It's because of your test. It's a high grade. Your 92.79.
Okay. A couple of comments. I noticed a couple of you actually show work that you were checking your answers back in to confirm, which is great. Several of you that missed some of those substitution elimination problems, if you had checked your work, you probably would have figured out that your answer was wrong and you could have gone back to fix it, but I didn't see any work there to show that you checked it. So I'm not counting off if you don't check it, but I'm just showing you that that's a good way to know whether you got the answer right or wrong by checking your work. Then you could have gone back to fix it and gotten more points back. I noticed a lot of sign errors. And for most of you, if I found one, I corrected them for you. I mean, I showed you where the error was. So if you understood the process, and I could tell from your work that you really knew what you were doing, but it was a sign error, you did get partial credit. I didn't just mark it wrong. But that's kind of what I told you at the beginning. It's really easy to do something a really simple math error that throws the whole problem off, which is why it's really important to check your work when you're done. Okay. All right, so let's just go through it. The first question said use a graph to solve the system. So in order to get credit for this, I had to see a graph. And I didn't need to just see the graph, I needed the solution because it said solve the system. So I needed to know what the solution was. I wasn't going to just rely on the fact that you graphed it and I'm supposed to know you know the solution based on that. The solution happens where the two lines intersect. I had a couple people, their graphs, one was obviously a negative slope and one was a positive slope. And so if you graph something, use some common sense to just ask yourself, does it make sense? If I look at both of these equations in number one, they both have positive slopes. So if I graph it, and my graph is that one of them is a negative slope, I know I've done something wrong. That would be an opportunity for you to go back and graph it again. Okay? So these are all ways that you can check your own work, because these are things that you know and concepts you understand. Just ask yourself, does it make sense? Does what I just did make sense? So if I'm using a graph to solve the system, if it's in slope-intercept form, I start at the y-intercept. So I start at -3 on the first one. And I use the slope of 5 over 1, 1, 2, 3, 4, 5 over 1, to find a second point and connect them with somewhat of a straight line. Then the next one, I draw -1, and I use the slope, 1, 2, 3 over 1. I just found the point just doing that. Because now when I connect these two, I can see there's the point that they intersect at 1, 2. Okay? If you just gave me 1, 2, but you didn't graph it, I have no idea that you didn't just look at the neighbor's 1, 2 and put that in. I need to know you know how to get the solution by graphing it. So I didn't give you credit, just giving me the answer. I needed to see the graph. Make sense? All right, next problem. Next two problems. All we had to do on these two is figure out whether there was one solution, no solution, or infinitely many. You didn't have to solve. If you did, that's fine to help find the answer, but you didn't have to. Okay? To know whether there's one solution, no solution, or infinitely many, the slope is your first key. If the slope of one line is not the same as the slope of the next, there is one solution. Because if the slopes are not the same, the lines are neither parallel nor the same line. Does that make sense? Okay, so the first place to look is just look at the slopes. Are they the same? Well, when I look at the first one, 4x minus 2y equals 8, and 2x minus y equals 7, the easiest way to find slope when it's in standard form is negative a over b. So for the first one, negative a over b is negative 4 over negative 2. And the second one, negative a over b, the slopes are the same. So I know for sure one solution is not going to work. These lines are not going to intersect at just one point. They're either going to be parallel lines or they're going to be the same line. That makes sense? Okay. So from this point, though, I don't know whether they're parallel or the same. I can do a couple of things. One thing I could do is figure out the y-intercept. Because if they're the same slope and the same y-intercept, they're the same line, right? To do that really easily, to find the y-intercept, I just hide the x term, right? X is 0. So when I hide the x term, y is negative 4. When I hide the x term, y is negative 7. Don't have the same y-intercept. So these are parallel lines, not the same line. Another way I could have done it is I could recognize 2 times 2 is 4. Negative 1 times 2 is negative 2. 7 times 2 is not 14, or not 8. Right? So that would be another way. So they have the same slope, different y-intercept. Therefore, they are parallel lines, no solution. Okay? If you had gone through the work and solved this with either substitution or elimination, which is fine, you would have gotten an answer like 0 equals 8, 8 equals 16, something that makes no sense. That would never happen. That's your cue that these are parallel lines and there will be no solution. They will never intersect. Okay, everybody follow that logic process? Okay, let's look at the next one and apply the same process here. What's the slope of both of them? close. What is it? Negative a makes it 3 over b is 3 over 3 is positive 1. Right? Slope of the first one is 1. Slope of the second is 1. Therefore, I definitely know one solution is not the answer here. But now I've got to figure out, are they parallel lines or are they the same line? Okay? One way to do it is just figure out what factor I need to multiply this by to get this and see if it works on every one. Well, this is 1.5. This is 1.5 times 2, right? Negative 1.5, I should say. So I multiply 2 times negative 1.5, I get negative 3. When I multiply negative 2 times negative 1.5, I get 3. When I multiply negative 6 times negative 1.5, I get 9. Same line. Okay, another way to do it is just solve for the y-intercept for both. When I cover this up and solve, y is 3. When I cover this up and solve, y is 3. Same y-intercept, same slope. They are the same line. Therefore, infinitely many solutions is the answer here. Where the two lines cross is everywhere that they are on the line, because they're the same line. I put one line over the other, they're going to cross at infinitely many solutions forever, because they're both the same line. All right, questions on just figuring out whether there's one solution, no solution, infinite number. Okay, number 4, use the elimination method. So I had to see work showing me the elimination method, even if you prefer substitution. Okay, so there's lots of ways I could do this. I'm going to choose to eliminate x, because one of them is already positive, one of them is already negative. I don't have to multiply one by a negative and one by a positive, which I would have to do with y. Does everybody see that? You can choose y. If you wanted to eliminate y, it should work just the same. I'm just trying to eliminate possibilities for error for me. Okay, so I don't have to multiply through a negative. I'm just going to multiply this by 3, this by 2, so that my x's become negative 6x, positive 6x. Okay, one of the places that I found a couple of you make mistakes, you multiplied these two terms, but you didn't multiply that one. Okay, make sure that whatever factor you're going to choose to multiply by, you do that factor to every term in the equation, not just the terms on the left. Okay, so when I do this, I'm going to get negative 6x plus 9y equals 24, and positive 6x plus 10y equals negative 24. When I add these together, my x terms cancel, which is the point. 19y equals 0. Divide both sides by 19, y equals 0. Once I know y, I can go back into one of my original equations and just substitute y in. Well, if y is 0, I have negative 2x equals 8, so x is negative 4. Okay, I think this is my answer, but just to check, I'm going to go into the second equation and see if it works too. So 3 times negative 4 is negative 12. The 0 goes in, that goes away. Negative 12 equals negative 12. Check, it works. So I know negative 40 is the right answer. Questions on that one? Substitution is the next one. 4x minus y equals negative 7. And negative 3x plus 2y equals 4. I appreciate having extra paper to do your work, but a couple of you, be really careful when you're writing the problem down from the first page that you're writing the right problem down. I had one of you, I think, write the problem down and then you forgot one of the signs. So if you write it down wrong from the beginning, you're never going to get the right answer. Another, I think, wrote I don't remember who it was, wrote this equation from number, or maybe it was the previous one. I don't know, maybe I've even skipped ahead. But they chose the second equation from a different problem. Yep. So what I do for that, though, I recognize we're not perfect. And if you did the work correctly, even if the problem was wrong, I think I just took a quarter point off because you just didn't transferred the problem over right. Okay, so just be really, just be really careful on, if you're going to rewrite the problem the way it's written. Okay? All right, this is substitution. I'm going to choose y. I think most of you did choose y, but several of you had problems solving for y. Okay? What I would probably do is I'd add y, and then I would add 7. Y is equal to 4x plus 7. Several of you had y equal to negative 4x minus 7, or y equal to negative 4x plus 7. You got the sign wrong. Okay? In order to get the substitution problem right, you've got to solve for a variable, and that equation that you get has to be correct, or the rest of the work is going to be wrong. Okay, so there's the equation, y equals 4x plus 7. You do not substitute this back into the equation you got it from. I had one person do that. You put it into the other equation. So I'm going to put it in here. Negative 3x plus 2 times 4x plus 7 equals 4. Negative 3x plus 8x plus 14 equals 4. 5x plus 14 equals 4. So 5x equals negative 10. X equals negative 2. Now I'm going to take x and I'm going to put it back in. I'll put it here. 4 times negative 2 is negative 8 minus y equals negative 7. Add 8. I get negative y equals 1, so y must equal negative 1. So I think the point should be 2, negative 1. Actually, negative 2, negative 1. Yeah. But to check it, I'm going to put it back in here. Negative 3 times negative 2 plus 2 times negative 1 should equal 4. Negative 3 times negative 2 is 6. 2 times negative 1 is 2, negative 2. And 6 minus 2 is 4. So it works. Negative 2, negative 1 is the solution here. Okay, next one. Tell whether the linear system has infinitely many, one, or no solutions. Okay, what's the slope of the first line? It's negative 1/2 divided by negative 2, right? So I could rewrite that. Divide by negative 2, multiply by the reciprocal. So that's 1/4. What's the slope here? Negative 3 over negative 12, 1/4. Slopes are the same. So I know it's not one solution. I could just recognize that if I multiply this whole thing by 6, I get the same equation. They are the same equation, therefore there's infinitely many. Okay? If you don't see it right away, solve both equations for y. Then you'll see that the equations are the same. Okay. Number 7 is 5 negative 2 a solution. So all you had to do here is just plug 5 negative 2 into both equations. So when I put 5 negative 2 into this one, 2 times 5 plus 6 times negative 2, I ask whether or not that's equal to negative 2. 10 minus 12 is in fact equal to negative 2. So it works for the first one. 5 negative 2 in the second. 2 times 5 is 10. Minus 2 is not equal to 6. Therefore, it is not a solution. Okay, it has to work in both equations to be a solution to the system. Number 8, solve the linear system. Several ways you could do it. The easiest to me looks like substitution, maybe, because I've already got y equals something. So I'm just going to take negative x in for y. 2x minus 2x equals negative 5. So 0 equals negative 5. This tells me they are parallel lines, no solution. Most everyone got that one. Last two, you get to solve however you want. This one, I would prefer elimination. That's my personal preference. I know if I do substitution, I'm going to end up with a fractional equation. So I'm going to just go ahead and do elimination. And I'm going to choose y's because I already have a negative and a positive, so I don't have to multiply by a negative. Is there anyone still struggling with how to figure out what to multiply them by? Everybody's okay there? We'll assume Ethan is. Okay. Don't forget to multiply every term in the equation. Several of you, again on this one, distributed the 4 to both of these, but forgot this one. Or maybe you got that one, but forgot this one. Just take your time and be very precise. So now when I add these, negative 13 over 25 is what I get for x. Now I'm going to substitute negative 13 over 25 back into one of my two original equations. So let's just do it in the first one. At this point, I think there was at least one person who tried my trick of multiplying everything by the denominator, which is fine, but when you multiply this by 25, you don't multiply the 25 by the 4 and the 25 by the negative 13, because this is all multiplication. Okay, so if I multiply everything by 25 here, it cancels this. And that's it, I'm done. Then I just multiply 4 times negative 13. And then 25 times negative 3, and 25 times negative 1. Okay. You could have gone ahead and forgotten using this trick because it confuses you, which is fine. Then you would have had negative 52 over 25 minus 3y equals negative 1, and you would have had to do fractions at that point to solve. But getting rid of it, what's that? But you multiplied by 4 also, didn't you? You got 100 or, yeah. So when you multiply, I don't distribute the 25 to everything. That's only if I have an add or subtract in parentheses, right? All I do is I take 25 over 1 times 3 over 25 times 4 over 1. So I can see right away that cancels, and I just have 12. It's not 25 times 3 and 25 times 4, and then I divide it by 25. You know what I mean? Okay, so now I'm going to solve. I'm going to add 52, that's 27. Negative 27 over 75, which can be simplified by 3, negative 9 over 25. So x was negative 13 over 25, y was negative 9 over 25. If you'd taken the time to go back and put it in for x and y in the equation, you would have found these were right. If you didn't get this answer, my guess is you didn't substitute your answer in to check, because you would have seen it was wrong if you had. Okay. The last one, a couple of ways you could solve this pretty easily. I had two people graph it. There's an easy way to solve it. Okay, if I graph these two, down 4 over 1. 1, 2, 3, 4 over 1. Let's go one more. Down 4 over 1. So there is my first line. Second, 1, 2, 3, 4, 5. Down 1 over 1, down 1 over 1, down 1 over 1. There's the intersection point at 3, negative 8. Okay. If you didn't graph it, another easy way to do it, we're given y equals for both of them. So if y equals negative 4x plus 4, and it's also equal to negative x minus 5, I can just set negative 4x plus 4 equal to negative x minus 5. Right? Because they both have to equal y. So they have to equal each other. Add x to get negative 3x, subtract 4 to get negative 9, divide by negative 3, x is 3. Plug that in to one of the two equations. If x is 3, I'm going to plug it in here. Negative 3 minus 5, negative 8. I could substitute it back into the first equation, negative 4 times 3 plus 4, and that is true. 3, negative 8. Okay, you've got a little over 15 minutes. Those of you who want to retake the test at some point, you need to get through the Khan Academy lesson. Those who are not intending to retake the test, you can, if you haven't already, watch 3.5's videos and textbook and be ready for the textbook check tomorrow. Okay, so we'll do 3.5 tomorrow, 3.6 Monday, probably review. I might give you 2 days on 3.6. And then we'll have a chapter test next week sometime. All right. Because everybody did pretty well, I mean, I had a lot of people do pretty well on this quiz. If you want to retake it, I will average the 2 grades. I won't let you retake for full credit.